Okay, welcome back from the lunch break. As our previous session was about science, current session will be about business or how to connect business with science. And first speaker, I think will not need big introduction in satellite remote sensing and geoinformatics landscape in Estonia. And Kaupo Voormansik represents Capaceta, which is a spin-off of Tõravere Observatory. And so, Kaupo, the floor is yours.
Very much. Can you hear me?
Yes, we can hear you.
Perfect. Do you also see my screen?
Yes, exactly. You are not in presentation mode. Now you are. Okay.
Okay. Now you see. Perfect. Thank you very much for inviting us to talk. I will talk not only about business, but also about some other topics, abusing my opportunity to talk. Quickly telling who we are, what we do. Then Martin asked me to tell about the use cases of SAR data, synthetic aperture radar data. As you know, ESTHub is also supporting Sentinel-1, which is a synthetic aperture radar satellite. Then we are telling an example how we use the Sentinel-2 WMS of Estonian landboard in Capaceta. Then we have some ignorant ideas how to make ESTHub even better and future-proof. I will quickly talk about Kaupo mask, a free and open Sentinel-2 cloud mask, which is currently in development in Capaceta, and finally about the main topic, the Sentinel-1 analysis-ready data. So we are Earth Observation Services company, and as Martin said, the spin-off of Tartu Observatory. We exploit a lot of synthetic aperture radar and deep learning technology, but we don't say no to optical data as well and other machine learning methods. We concentrate on agricultural applications, more recently also on agricultural insurance we are looking into. And the other thing where we see the growth is making Sentinel-1 SAR data layers, or so-called analysis-ready data layers, more easily available to various business-to-business and business-to-government users who can then develop several end user applications with this data. So we are currently a team of 13 people, and we are still looking to grow. We have offices in Tartu, aparaaditehas, and in Kuressaare. So not everything needs to be in Tallinn. Currently our office is half empty because of the corona restrictions, but we are very much waiting for the situation to end so we can meet with the whole team again in the office. So what one can do with SAR data? It's a very good question. And very correctly, SAR is called Earth Observation Multi-Tool. So it's like this Swiss Army knife that you can do a lot of things with the same instrument. To be fair, then not all of these applications are possible with Sentinel-1. The global DM, for example, is made with SAR data, but one cannot do DMs with Sentinel-1. But still with Sentinel-1, one can do a lot. So the first use case, what I would say is like very general one, is it is just a very frequent satellite image. Sometimes you just need to have a fresh look of your landscape, just like how it was yesterday, your forest, your agricultural field, some mining area, sea areas, and so on. So the visual check is sometimes what is needed. And here Sentinel-1 has a good advantage thanks to the weather and the illumination independence. It provides about 5 times denser usable time series than Sentinel-2. Then it has a data layer called coherence, which we have been exploiting a lot. Also praising here Tauri Tampu, University of Tartu PhD student who have shown its applications for peatland studies. So it's a layer which shows you the change. It's a normalized change measure between 2 images. And you can see the change which human eye cannot see, which is like really cool. And in the peatlands, for example, you can see where the peat has been extracted, even when visually you don't see any difference. Or the same application for higher resolution is that you can, in the desert areas, for example, you can see where somebody has hidden explosives, like somebody has turned the soil upside down, and you can see the coherence loss in these areas, even if visually you don't see it. And last but not least, coherence is actually a very good proxy for estimating the amount of vegetation. So coherence is low when the vegetation is high and vice versa. And this fact is exploited a lot for the mowing detection for PRIA, Estonian Agricultural Subsidies Paying Agency. Then you can do fine phase measurements for land and buildings drift estimate. I don't go to details into this because I know Antti will talk about it next, about the SILLA application, exploiting differential SAR interferometry, more precisely to call permanent scatterer or persistent scatterer SAR interferometry. But Antti can talk about this. This is really cool. You can see the drift with millimetric accuracies out like from 700, 800 kilometers apart from space. And it really works. And it's very, very cool. Then another cool thing you can do with SAR is, as the time series are so dense, you can develop so-called temporal signatures of several objects like agricultural fields. Why not also a building? Why not a forest parcel? And like based on like how these objects behave in time, they form different signatures. And it is very nicely complementing the optical data. And our results show that making the crop classification only based on Sentinel-2 would have resulted in way poorer results than together with Sentinel-1. So use all the data sources you have, and radar and optical very nicely complement each other. Then it is sensitive to water. Radar is basically seeing the world as antennas. Everything what is conducting is visible for it. And in the nature, it is mainly water and metals. No metals you don't have so much in the nature, then water is left. And you can do flood mapping with synthetic aperture radar. And you can estimate the soil moisture, which is fair to say it works well for bare fields. It is more tricky when you have vegetation and you try to estimate like how is the soil moisture under the vegetation. It's not so accurate anymore, but bare soils, way to go. And we could extend this list a lot, but I know I have just 15 minutes, so maybe it is enough. I encourage everybody to use SAR data. It's a very exciting world and a beautiful instrument. Then in February, Maa-amet launched ESTHub Sentinel-2 WMS service, and it's really good. Our impression is very positive, and we are already using it in one of the pilot projects for Estonian farmers, where we estimate crop harvesting time. And we used the visual layer and the NDVI layer from Maa-amet WMS, nicely referencing to Maa-amet, of course. Yeah. And then we have some further ignorant ideas, like how one could make ESTHub even better and future-proof. Then I think today's event is really good initiative. It's like talking regularly with users, and I mean really all companies, researchers, public sector users, including PRIA and all the others. So today's event is a great thing. Keep doing it. Then looking at the future, to make ESTHub software environment the ideal would be that it is fully compatible with other Earth observation platforms. So what I mean with this, for example, now when we are planning this WMS service, then we have a choice like to making it to ESTHub, making it on a DIAS. And if the environments are very different than to do a Europe-wide service or Estonian service, we have to do double the development. And this is extra cost. So if you could make ESTHub ideally fully compatible with other European Earth observation platforms like DIAS, why not also go Euro Data Cube? I don't know actually how mature they are and how usable it really is. But keeping an eye on the other European Earth observation platforms, which are kind of like trying to do similar thing to ESTHub, it's a good idea, I believe. And this enables Estonian applications to go around the world more easily, and also vice versa, to use the best international practices in Estonia more easily. So compatibility is a good thing. Then one more thing about Sentinel-2 before we go to the radar world. We are developing a free and open cloud mask called Kaupo mask for Sentinel-2. And we started for terrestrial summer season conditions. So marine users have to be disappointed at first. But many terrestrial users, we believe, are already happy. Agriculture, forestry, and so on. We used the latest AI technology for it, and the first version of it should be ready this summer. And like Martin introduced, like we are somewhere in between science and business. So this thing is will be distributed freely, as it is also developed with public funding. We are most happy if people start to use this cloud mask and give us feedback. According to Margarita, I talked with her this morning, the first version should be ready in August. And you can talk with her directly if you want more info about it. Internally, we are already using it, and we are really pleased with the accuracy. Here are some examples comparing our cloud mask with the current existing ones like the Sent2 Core, which is incorporated into Sentinel-2 standard data products, and the F-mask from US. And we are pretty convinced that ours is more accurate. You can convince yourself, and we are also publishing a research paper about it, which studies the accuracy more rigorously and sees where are the errors and what are the actual objective accuracy figures. Yeah, that's about it. Then going to the main topic. I hope I still have some time. 2 minutes. I hope I don't go too much over time. I apologize for it. So Sentinel-1 analyzes ready data. So the thing is that the SAR data is not much used. We think not because SAR is complex, but using of it is complex. And you have to do a lot of pre-processing before getting some value out of it. So because of this, a lot of users just drop it and they cannot feel the benefits. And we believe that if we could do the complex pre-processing for the users and just provide the analysis ready data layers, a lot more users would use it. So the ideal is really to have one-click integration and use. You just switch on the SAR layer as a WMS or import it to your API for machine-readable applications. And we have started to work in this direction. Here is the list of the services we are planning. There are 6 lists. You don't need to read it now and understand all it. The idea is extremely simple. It's just making the best machine-readable and visual SAR products and making them dumb easy to use. So one-click integration, you have the SAR layers. Here is an example of our Sentinel-1 WMS service. It's compared to Sentinel-2, it's way more frequent, and because the clouds are not disturbing it. Sure, the radar image looks a bit weird, like this kind of like purple, greenish, gray tones. Not very natural to use, but Our experience shows that interested users learn even the weird data sources quickly until they are convenient to use. Here is an example of agricultural land of Estonia last summer. And the whole idea, or like I would say one of the largest use cases is it's just the most up-to-date satellite image. How was your forest yesterday? How was your field yesterday? You can check it from this layer. And not only this, you can go back to some specific date of time, like you have some claim, for example, some government authorities have some arguing with somebody says it was like this, it wasn't like this that day. You can scroll back and see how it really was, this forest or mining area or agricultural field. Here is an example of how we do the noise suppression. So the original SAR image looks like a noisy, like old TV. Some of you still remember the black and white TVs. And when we do the best noise suppression and calibration for this data, we are able to save the same spatial resolution, but effectively suppress the noise. Some further crazy ideas is that Sentinel-1 is ugly but frequent, Sentinel-2 is beautiful but rare. Okay, then let's make Sentinel-1 look like Sentinel-2. And with AI, we have managed to get quite promising first results, though a lot of work needs yet to be done. Credit to Heido Trofimov in our team and his colleagues. It's really exciting. So maybe one day the Sentinel-2 WMS can be much more frequent, which is actually faked of Sentinel-1 data. Okay, I'm wrapping up last slide. So to make this all beautiful future happen, we are currently submitting a funding proposal to ESA Incube program. The development should start in August this year. We received conditional pre-purchase letters from PRIA, e-Agronome and Teraki Workfields. Thank you very much. You have made very valuable support to us. And we are in talks with Estonian Environmental Board, Keskkonnaamet. I would like to thank Jaanus Müür and Janar Aleksandrov for the initiative. We don't have no deal yet, but I'm hopeful. And I would like to underline that we really need other governmental users also to come along. Like PRIA is brave and strong, but they alone shouldn't drive all the requirements and pay for the services for the whole Estonia. So other governmental users are also much needed. And that is all. Thank you for listening.